Hello, hello, hello. Section 4.2, proving triangles are congruent. I don't know why I said section 4.2. We're in section 4.4. Section 4.4, proving triangles are congruent by SAS and HL is what we're going over right now. And we've already learned how to use the side angle side congruence postulate in order to prove the two triangles are congruent. What we're going to focus on today is the HL part, the HL standing for hypotenuse leg. And we're going to use the hypotenuse leg congruence theorem, not a postulate, but a theorem, in order to prove that pairs of right triangles are congruent. Alright, so a couple things for me to focus on here. First of all, this is 4.4, so let me change that. And then the next thing I want to focus on is the fact that this is a theorem, not a postulate that we're learning here. Every other way we've learned to prove that triangles are congruent has been a postulate so far. We're going to start learning theorems from this point on. And then the last thing, and probably the most important thing about HL that I need to point out, is that it's used to prove that right triangles are congruent, and it only works to prove that right triangles are congruent, and then only some of them. There are other ways to prove that right triangles are congruent as well, is what I mean to say by that. Alright, HL congruence theorem. Well, since this is the first theorem to prove that triangles are congruent as opposed to being a postulate, I want to reinforce that fact by writing a proof of the hypotenuse leg congruence theorem. Remember, what differentiates a theorem from a proof is that, a theorem from a postulate is that a theorem is a fact that is provable. A postulate is accepted as true without proof. So, let's write the proof that shows you why the hypotenuse leg congruence theorem works. And then, of course, I need to explain in the process what the heck the hypotenuse leg congruence theorem is. Copy down this information right here, and then we'll write the proof together. Now, what the hypotenuse leg congruence theorem would say is that if the hypotenuse and one of the legs of a right triangle are congruent, to the hypotenuse and a leg of a second right triangle, then those right triangles are congruent to one another. You can tell that's not quite side angle side, right? Because the congruent angles here are not the included angles of the two congruent sides. But nevertheless, right triangle, hypotenuses are congruent, the legs are congruent, one pair of legs, and we're going to try to prove that the triangles are congruent to one another. Hypotenuse leg theorem would say that they are all the time. And so in order to help us with that, I've made it so that segment AC and segment DF are both the same length. They're both y units long, so the hypotenuses will be congruent. And I've made it so that segments A, B, and DE, each a leg of their respective triangle, are the same distance. They're both x units long, so we got a pair of legs that are congruent. And then I told you that the two triangles are right triangles right here. Okay, so we've assumed everything necessary for the hypotenuse leg congruence theorem. Now we just got to figure out why this would have to be true. Well, let's start off by just stating some of the things that are given to us. Starting with the fact that the two triangles are right triangles. And then let's talk about a strategy for how we're going to prove that the two triangles are congruent. We're going to actually use the side-side-side congruence postulate to help us with this. And here's how that's going to work. In a right triangle, the Pythagorean theorem is at play, correct? And if you know any two sides of a right triangle, you can find the third side using the Pythagorean theorem. And so, knowing the two side lengths of this triangle and this triangle, we can show that the third side lengths are both equal to one another. Now, I'll let you actually do the Pythagorean theorem to figure out what or why this is true, but I'm going to go ahead and write down what those distances are for right now. Turns out that this third side BC and EF of each respective triangle are both this length. The square root of y squared minus x squared. Alright, I think you can understand why they would be the same, even if you're not sure why they would be those values in particular. Well, so that means that we could prove that all three sides of this triangle are congruent to all three sides of that triangle, which would make the two triangles congruent to one another. Let's go through that proof and just follow what I do for these first couple steps. Let's write down the rest of this given information. and use it to show two things. One of those things being that segment AB and segment DE are the same length. And the other of those things being that AC, the length of that segment, equals the length of EF because of the transitive property of equality. And that, of course, makes those two segments congruent to one another. Those two pairs of segments, are congruent by the definition of congruent segments. Now, in terms of our checklist of where we are on the proof, we just proved that two pairs of sides are congruent to one another, so I'll put an SS there. We still need to show that the other pairs of sides are congruent, and we'll do that this way. We found out that BC and EF are each this distance right here. That using the Pythagorean theorem. Quick note, I had to change all those EFs to DFs because I miswrote that in the problem. So you can change those previous few EFs to DFs, please. Alright, and since BC and EF are both the same length, by the transitive property, they're congruent to one another. By which I mean first their lengths are equal, and then we can say the two segments are congruent. That then showing the third pair of sides that we needed in order to prove that the triangles are congruent, and now I'll state that the triangles are congruent using the SSS congruence postulate. Alright, it's rare that we actually take the time to prove a theorem, even though they're all provable, but I wanted to do that in this case to make sure you understood why we would call this a congruence theorem as opposed to a congruence postulate. Alright, in the future, if you saw this information right there, you would just be able to directly, maybe in 2 or 3 steps, state that the triangles are congruent by the HL, hypotenuse-leg congruence theorem, rather than having to go through this 8-step process to prove that the triangles are congruent by SSS. And you can appreciate that, I hope, from looking at the amount of work that we did right there. Alright, well, let's move on and talk about what the HL congruence theorem is more formally, and then there's only 2 more proofs that we're going to attempt in this video, and we'll go through those to show you how to use the HL congruence theorem. Now, the HL theorem is going to say this, that if a triangle ABC and a triangle DEF are right triangles, segment AC is congruent to segment DF, or in other words, the hypotenuses of the right triangles are congruent, and one pair of legs, in this instance segment BC and segment EF are congruent, then the two triangles are congruent to one another by HL congruence theorem. Very simple. Alright, so make sure you're never trying to use HL if you don't have right triangles, but if you have right triangles, it's a good idea to look and see, do they have congruent hypotenuses and congruent legs? Take a look at a couple of proofs that we're going to try to do here. You need to copy down this given information, and I'm willing to bet with the few congruent triangle proofs that we've done already that you've got a good shot of completing this on your own right now. If you think you can, go ahead and do it. If not, watch this one and then try the next one on your own. Now let's take a look at what we know about these two triangles based on the given information. We see that segment LT is perpendicular to segment TE, which would of course make this a right angle, angle LTE. And then we also see that segment TE is perpendicular to segment E, well that's supposed to be a B, not an F. It's perpendicular to segment EB, and so that makes this a right angle right there. Let me fix that F, change that into a B. There we go. Okay, we also can see that segment LE there is congruent to segment FT or BT, excuse me, right there. Now, does that give us a pair of congruent triangles? Well, it does if you also include one more thing. You're getting used to this by now, I hope as well. By the reflexive property, these two triangles have segment ET that is the same length. So we'll have a hypotenuse leg situation. We've got right triangles, right? There's a right triangle. There's a right triangle. And they've got a pair of legs that are congruent to one another, which just happen to be the exact same segment. Right? Those are congruent. And then you've got the hypotenuses congruent to one another. So you'll be able to use the HL congruence theorem in order to prove that those triangles are congruent. Now, some things that need to happen for that to work. You have to prove that you've got right triangles, then you have to prove the hypotenuses are congruent, and you have to prove that they have a pair of congruent legs. We haven't yet proven that these are right triangles. We just know that there happen to be some perpendicular lines around. So the proof starts with you using the pairs of perpendicular lines to prove that these are right triangles, and then moving on from there. Let's do that. I'm going to go ahead and write both of these perpendicular line facts in the proof. Now, as far as proving the triangles are right triangles, a right triangle is a triangle that has a right angle. So we've got to prove that these two angles here are right angles, and we're ready to do that now that we've stated that they're formed by perpendicular lines. And the fact that those are right angles is supported by the definition of perpendicular lines. And so then the triangles LTE and BET are right triangles. The reason you know that triangles with right angles give you right triangles is by the definition of a right triangle. Alright, so we've done the part where we've proven that it's a right triangle. That's necessary. Then you got to prove that the hypotenuses are congruent and that the legs are congruent to one another. One pair of legs is congruent. Let's start with the hypotenuses because that's what was given here anyway. Segment LE is congruent to segment BT. As far as kind of our report card for this HL proof, you got to prove there's a right triangle. We did that back in step 3. You got to prove that the hypotenuses are congruent to one another. And now we're about to prove that the legs are congruent to one another, and that's because it's the exact same segment and we're using a reflexive property. And once you've taken care of those three things, right here, here, and here, then you're able to prove that those right triangles are congruent using the HL congruence theorem. So there's one proof using the HL congruence theorem. I'm going to want you to try another one here, the last one for this video. You've got enough information and enough experience at this point that you ought to be able to figure this out. Now, when I say that, actually there's two ways you ought to be able to do this. There's a way you ought to be able to prove that these triangles are congruent using side angle side. There's a way that you ought to be able to prove using HL that these two triangles are congruent to one another. I would prefer that you use HL right now just because that's the video that we're watching, the skill that we're trying to learn. But I would encourage you to also maybe see if you can do this by SAS. I'll let you try one or the other, then I'm going to prove it by HL. Alright, I've already written in the first statement and reason here. You ought to know that if you're trying to use HL, which I told you could for this proof, that you're going to try to prove that the triangles are right triangles first, and that's going to stem from the fact that the triangles have right angles, which was nicely given to us right there. Let me go ahead and start marking some other information on the picture to see where we go from this point, but that is the beginning. So the fact that segment or the angle D and angle F are right angles makes these both right triangles, right? That'll be the next step in our proof. Then afterwards, we're going to have to show that the hypotenuses are congruent to one another, which is going to be true since M is the midpoint of segment AQ. There you go, those two distances, the hypotenuses will be equal. And then, since M is the midpoint of segment DF, that's going to make segment DM congruent to segment FM. And that's a pair of legs for those right triangles. So that'll make the triangles congruent by HL. Alright, let me continue with the proof then. There's our conclusion that the two triangles are right triangles based on the definition of a right triangle, that they have right angles. So that takes care of the right triangle portion of our little checklist that we use for the HL congruence theorem. Next, we want to try to prove that the hypotenuses are congruent, which is based on the fact that M is the midpoint of segment AQ. A fact that is given to you, which then leads you to conclude that segment AM is congruent to segment QM by definition of midpoint. Alright, so there's the H taken care of. Now let's go to try to show that these two legs are congruent, which is based on the other midpoint fact that M is the midpoint of segment DF. Thus, you've got that pair of congruent segments DM and FM. And there you go, you've got the proof. That was the L part of the HL. And so now you can go ahead and state that the two triangles are congruent by the HL congruence theorem, and that's it. We've got plenty more proofs of triangles to go with the next several sections, but you've got a good basis with SSS, SAS, and the HL congruence theorem to understand what this chapter is about so far. I hope this is making sense and that you're able to do some of these proofs on your own. Good luck with the assignments. I'll see you in the next video and in class.